In this video, we will be demonstrating how to work with Nuvoton board. For this, we will be considering the three basic experiments. The first experiment will be blinking of the internal LEDs, and the second experiment will be the display of RGB colors, that is the basic colors, and the third experiment will be the switch control of buzzer. Now we will be going to see the how we will code the Nuvoton board. For Nuvoton board, we have we included a header file called drv.gpio.h. It includes all the necessary functions which we will be using in this function, and we will use the I as an integer variable. This will be used for generating a loop purpose, and we will use this delay counter variable. This is used for generating a required amount of delay to identify the on and off of various LEDs. These internal LEDs are connected to GPC 12, 13, 14 and 15. And the characteristic feature of this Nuvoton board is active low. Active low means if you want to turn on the LED, we have to give 0 to that port, and if you want to turn off the LED, we have to give 1. And we have used while 1. While 1 is used for, it is representing a continuous or infinite loop. Since we want our LEDs to glow continuously, we have used this while 1 serves for our purpose. Here we are on and off the LED continuously, and we are giving the required delay. The delay is used to differentiate the on and off of various LEDs. Now we will give a video how the experiment works. You can see that the LEDs are blinking continuously and they are moving from one LED to another. These are GPC 12, 13 and 14, 15 which we have coded in our program. Now we will go to the second experiment, that is RGB. Same, we need to include the same header file as far as previous program, and this I and delay counters serve the same purpose. But these RGB LEDs are connected to different ports, and these are the differentiation between the previous program and this program. These RGB LEDs are connected to GPA 12, 13, 14, and the same while loop concept is used. And we are making on one LED at a time. At the first experiment, we are making on the R LED, since it's a Nuvoton or active low, we are giving 0 to that 12, which makes the LED red to get on. And after this count is a function. When this count comes, the control goes here, and the required amount of delay will be executed so that the different colors can be identified. Similarly, after that, we will make the green LED on, and we will make other LEDs as off, and we will give the required count. And similarly, the delay will be generated, and after that we will make the blue LED on, and the required delay will be generated using this count function. And since we have kept this in a while loop, the loop will execute infinite amount of time, and the LEDs will be glowing continuously until the user interrupts to stop. And now we will show the video demonstration of this. Here we can see the red LED is glowing, and now it is changing it to green after some particular amount of delay, and it is changing it to blue. And we can see that once again the LEDs are repeating since we have kept the program in the while loop. This is as for concerning about the RGB LEDs. Now we will go for the next experiment, that is buzzer. In this experiment, what we are performing is a switch will be connected to GPU board 15, and when that switch is pressed, the buzzer has to turn on. The same header file will be including, and this 15 indicates the switch, and these are the LEDs, and this 11 indicates the buzzer port. if GPB GPB underscore 15 means whenever the user presses a switch, will get it as 1, and the control enters here, and we are just making the buzzer to turn on, and at the same time we are making the one internal LED to on. Now we will see the video demonstration of this. Now we can see when the buzzer is pressed, the LEDs are getting on. The internal LEDs are getting on. And when the buzzer is off, the LED is getting off. This is how this buzzer program works. This is as far as the Nuvoton board experiments. Thank you.